Wait, Miss, are we supposed to simplify this?
I think that's okay. I think you have it right. Okay, so we're going to talk about simplifying, adding, subtracting, multiplying, dividing, rational expressions.
So Miss, for S, like, we could leave the answer like this, right?
Yeah. Let's see. I'm not sure yet, so let's see. Okay, so you guys, listen. Jiva. Okay, so today we're going to talk about rational expressions. What about them? How to oh, you guys can't see this. I'm sorry. We're going to talk about simplifying them, adding and subtracting them, and multiplying and dividing them. Okay? This is an example of adding and subtracting rational expressions. Usually if I bang, projector starts working. I don't know what it is. So weird. All right, I guess I'll just use this. Okay, so all right. So before I wanted to kind of go into like kind of explaining how everything works, but before that, since you guys did this as a little warm up, let's actually talk about it. So, how in the world? Okay. Okay, so we're simplifying, adding, subtracting, multiplying, dividing rational expressions. All right. Okay, the thing about a rational expressions is when you're subtracting them or adding them, you have to have what? The common denominator. In order to have a common denominator, well first thing we do when we see fractions like this, what should we do? Put parentheses, okay? Always just do that off the bat, okay? Okay, now I want a common denominator. So the least common multiple is if I multiply this side by x minus 2 and this side by x minus 3. That way, hey, now we both have the same denominator, right? But obviously I can't just start multiplying stuff out of nowhere because math is supposed to make sense. But that does make sense if I multiply x minus 2 on the top as well. How come? Because x minus 2, that's just a rule. But what's x minus 2 divided by x minus 2? 1. And if you multiply by 1, does that really change the fraction? No. So that's why it's allowed, right? You're just multiplying it by 1. Well, this one, if I wanted to make this one, what can I do? I can multiply this by x minus 3 on the top. You see that? Yeah? So now let's just go ahead and simplify that. This is 5 times x minus 3. I'm going to distribute that 5, so it's 5x minus 15, right? Yeah. Over x minus 3 times x minus 2. Minus, parentheses, 2x plus 1 times x minus 2 all over x minus 3 times x minus 2. Okay? Do you guys agree with that? Yeah. Do I have a common denominator now? Yeah. If something has if two rational expressions have a common denominator, we can actually combine the fractions, keep that common denominator. Do you guys agree with that? Yeah? And then on the top, I'm just going to do this. So it's 5x minus 15 minus 2x plus 1 times x minus 2. Okay? All we do is combine those two fractions into one fraction. Now this is where you can make a lot of mistakes. A lot of things can go wrong here. What do you guys want to do first? First? You can. You totally can. Is that what everybody did, Michelle? Cross out like terms? Like which one? Like these two? No, so that's a red flag. That's like a Miss Williams red flag.
So it'll be 5 then x minus 3. And then you do the bottom.
Then you'll be left with 5 over x minus 2. That's where we started.
No, you left with 5. 5 was 5 and parentheses x minus 3. And then you cancel out the bottom. You do the
Wait a minute. So you want me to factor out 5 from here?
we're just saying
What? I just want to try it since you guys told me. Factor out 5 times x like that? Wait. Okay. Yes? Like that? Okay, hold that thought. Wait, but some of you guys still want to do this.
we just do that and then we do that.
After. Can we do the...
Okay. So basically you left it like this, 5 times x minus 3. That's where we started. I distributed it on purpose. But if you want to leave that out there, that's fine. So you, okay, so an alternative is this. But if we, okay, wait, wait. It's too loud. If you guys are here just to eat, you could do that outside. The only people that should be in this room is if you're working. I have too many people in different groups doing different things, so it gets really hard if people start having separate conversations. So please, let's maintain a focused environment. Most of the talking should just be with this class. I need you guys to whisper about calculus. Any other conversations can be taken outside. I have no problem with that. Come back when you're ready, okay? But if you're here just to socialize, please do that outside. There's lots of space out there, okay? Now, if you wanted to factor this out, that's fine. But please do not decide to cancel this and this. Why can I not do that? Because if you cancel it from here, you would also have to cancel something from there, but there is no x minus 3 here, okay? So now Nichelle said we should, what is this called?
Distribute.
Double distribute, okay? Some people call it FOIL, okay? So let's do that. Okay, so that's going to be, don't forget the minus there, okay? We had 2x squared minus 4x plus x minus 2 all over x minus 3, x plus minus 2, sorry, x minus 2. Okay? Now what?
The x method?
No.
The 4x and the x, right?
Okay, the negative 4x and the positive x gives you what?
Negative 3.
This is negative 3x. Okay? Okay, so that's negative 3x. Now what? To factor this?
Yeah.
If you factor, you're going to get this. The point of x method is to factor, but we had just factored.
You distribute the negative and then you add the next.
Yep. I know you know this. You calm down over there, okay? What were you going to say, Nichelle? Okay, good. So that's a big mistake. Some people did not put the parentheses, so they thought this negative only applies to the 2x squared. But that negative should apply to who? Every term here. You see that? That's where people went wrong. So you got to distribute that negative here, and here, and here. Okay? So then I have 5x minus 15 minus 2x squared. That was a negative 3x, but now it should be what? Positive 3x. And that was a negative 2. Now it should be? Negative 2 is now it's a positive 2. Okay. Now what? Combine like terms. What did you say? Switch them? Switch or squish? Oh, squish. Okay, yes, combine like terms. Now, remember, if you had left this factored, at this point, can I squish these? Can I combine these with these? No. So what did you do after that? Because you factored this, right? Okay, so the factoring doesn't serve us because we want to distribute everything, expand everything so we can find all the like terms. Okay? Okay, so we have, do I need those parentheses? Among friends, if we're all the same type of people, okay, this is going to sound bad. Really bad. Do you guys ever act differently when you're with your own, like, ethnicity? like once you're like at school with everybody else, well, okay, school is a little different, but or a little same, but okay, then like you act a certain way, but then like with your family, you like act differently. Like I'm like that. Like if I'm around only Koreans, then I'll act differently because I have to follow all the Korean cultural norms. But if I'm like it's in a group that's mixed with Koreans and non-Koreans, then I won't do those things with them. For example, you have to be polite and bow and stuff with Koreans. But if I'm like at church and it's like not just Korean people, then I'm gonna see that I won't bow to them because I'm like, oh, well, this is not a Korean thing. Like, well, I'm not gonna bow. But if I'm all of a sudden at a Korean thing, like a Korean party, then oh, okay, all the bowing stuff and all that applies. Kind of like that. Okay. Okay, everybody here. And yes, yeah. Okay. Everybody here is the same. They're all adding or subtracting, right? So is it really necessary to have these parentheses? No, because when we're adding and subtracting, the order doesn't matter. It's addition and subtract. Addition is commutative, right? So I could just get rid of those. Now, if all of a sudden there was a multiply here, then can I just get rid of the parentheses? No. Oh, somebody else came? Okay, now. Okay, that sounds bad. That's like racist. But anyway, okay, so this is going really slow, but you guys need to practice this to the point that this should take you like a minute, okay? Not 30. Okay? What, Josue, what's that?
Number 18.
Zero or does not exist.
Ina, please report to the team office.
K of x or K prime of x?
Report to the team office.
For the second derivative test or first derivative test?
Alright, so the first derivative is undefined, right?
Wait, but which test are you doing?
First.
Okay.
So if you plug, so then first derivative is undefined, right? So when you plug that back into the original equation, the original equation is undefined, there's no critical point.
Right, it's not going to be a critical point if... Yeah, so it's not even a point. Yeah, there's nothing there. Okay, so now let's simplify. What like terms do we have? They have 5x and 3x. What's 5x plus 3x? 8x. And then we have the negative 2x squared. And then here's another like term, negative 15 and positive 2, which is? All over x minus 3, x minus 2. Okay? Am I done? Maybe I am, maybe I'm not. Okay? Why do I say that? What is the x method for? Factoring. Okay? What does factoring mean? Take out the multiples or like parse out what are the multiples that create this expression. Because why would I need to factor? Because, for example, what if I factored this? What if one of the factors is x minus 3? Then what could I do? I could cancel them out. So I have to at least try to factor. Okay? Do you see why I have to factor?
But even though you don't get the outcome doesn't come down to canceling out, can you just leave it like that?
You could, yeah?
Like,
okay, so what if I factored and I got x minus 4 and x minus 5 over x minus 3 times x minus 2? Is that still simplified? Yes. That's fine.
So it's still good.
That's still good. Yeah, so there's no harm in factoring.
Either way,
It's good to factor. That's right. That's good. Smart. And it's also smart because what if this was the same as this? Then I could cancel them out. By the way, can I cancel this out? Because this is a 4 and this is a 2 and just cross it out and make a 2? No! Ow! I got so excited that I hit myself. That's a red flag. You cannot do that. You can only cancel out multiples. Okay? Alright. So let's try to factor this. Okay? So we call this x method, but I don't want you to use the term x method. I mean, you do, but you use the x method to factor. Don't forget the word factoring. So what two numbers multiply to, what's negative 2 times negative 13? 26. Positive 26, and then there's my 8. I don't know if you guys put on the top or bottom, but okay. Doesn't matter. So two numbers that multiply to 8, and 26 and add to 8. So what are the multiples of 26? 1 and 26, 2 and 13. That's it, huh? Do these numbers ever add up to 8? No, so it's not factorable. So that is it. Okay? So where did people go wrong?
The negative.
The negative? You forgot to distribute which one? The negative? Okay, what else? What else went wrong? You got distracted? Oh no, you gotta believe in yourself. Actually, don't believe in yourself.
What?
Don't believe in yourself. Believe in logic. Believe in yourself as a logical person. Believe that your logic makes sense. So if everything you had done so far made sense, then don't doubt it. Okay? Alright. So let's go. It's very logical. Okay, now let's actually, if you guys have your Thanksgiving packet, I want to read to you a little bit from, I have a feeling most of you guys just skipped over these explanation pages. Maybe if you guys read them, but I'm going to just read through it with you, okay? Alright. You guys have this? You don't have to get it out, but if you want. Okay. Okay. Yes?
All of them? So when we type to 8, well, we have to call all 8 and say we failed.
Okay. Alright, so
This semester, we have to call it this semester.
and next semester.
But what if we only fail one semester?
Just every semester. Then you just call once. Okay. Alright, so simplifying rational expressions. Okay, you guys with me? Okay. Everybody else, please try to whisper. Rational expressions are fractions, okay? Fractions that have algebraic expressions in their numerators and the denominators, or one or the other. To simplify them, you have to find factors. Gotta find the factors that are the same and then write them as a fraction to equal 1. Okay, for example, 6 over 6 is 1, x squared over x squared equals 1, this over this equals 1, that over that equals 1. You guys agree with that?
Yeah.
Yeah. Notice that the last two examples involve yes, binomial sums and differences. Why is this called a binomial sum? It's a binomial because there's two terms, and it's a sum because you're adding. This is a binomial difference because it's binomial because there's two, and this is a difference because it's subtracting. What this was, where'd it go? This one is a trinomial because there's three terms. Okay? Alright. These two are binomial sums and differences, right? Only when the sums or differences are exactly the same does the fraction equal 1. If it was 3x minus 2 over 3x plus 2, are those exactly the same? So can you cancel them out and say it equals 1? No. Rational expressions such as example cannot be simplified. Okay, these are the red flags that Miss Williams was talking about. Are these the same? So can you go, woo, cancel? No. How many of you guys still do that sometimes though? None? Good. Okay, you cannot cancel these out. You can only cancel out, because when I say cancel, it's not really canceling, it's just simplifying to 1, and 1 can be invisible, right? Can you cancel these? No. Can you cancel those? These? No. I need you guys to like tattoo this to your forehead, okay? Okay? Cannot simplify those. Okay? Most of the problems that we give you will require that you factor the numerator. So if you can only cancel factors, then you're going to first have to factor. Okay? I'm going to ask you to factor. So even if it's just a regular number, like 12 over 54 with no x's, factor the 12, 223. Factor the 54, 2333. What can cancel out? Why? 2 over 2 equals 1. And now, oh, what else can cancel out? The 3 and the 3. So we have the 2 left, and then we have the 9, right? Because this equal 1 and that equal 1. So really, I have 2 over 9 times 1, which equals 2 over 9, right? Same thing here. Okay, we can cancel out the stuff that's the same. But when I see this, please do not think that you can cancel this and you're left with, and then cancel this and you're left with 1 over 5. Okay? No! Okay? The 430 bell is extra. It's just extra, okay? But what I can do, wait, it's getting loud. What I can do is factor this, and real quick, let's just assume that we can do it real fast. That's x minus 2 times x minus 3. This one factors to x minus 2 times x minus 3. So which ones can I cancel out? That's right. And so then my answer is x plus 2 over x minus 2. Okay? All three examples demonstrate that all parts of the numerator and denominator, whether they're constants, monomials, binomials, factorable, trinomials, must be written as products. What does a product mean? Multiplying only, not adding. Okay? So when things were being added, you can't just cancel stuff. The only reason I could cancel these are multiples. These are products. Okay? Once you have only products, you factored everything out, then you can start canceling. So basically, i.e., what this means is only cancel, that is so messy, cancel or reduce fractions once you have fully done what? Yes. You have to fully factor before you cancel anything out on a fraction. Does that make sense? Okay, so the only exception is with the negatives. These are special. Because here, negative 2 and 2 are not the same. But I technically can cancel it and get negative 1. Because really, I could factor this to negative 2. I could factor this to negative... I keep writing what I don't want to write. I can technically say this is negative 1 times 2 over 2, right? And then the negative 1 would remain. So I can technically cancel those and get negative 1. What about this? This came out on your test. Okay, these are not the same. So why am I trying to cancel those? First, I can do what? They both have a negative, so I can take out that negative. In fact, I could call it a negative 1. And then what's left? If I take out the negative, it's positive x and positive 2. And now they are the same. So now I'm left with negative 1. Okay? Please remember these. This is an important one, and so is this one. I talked about this with you guys this morning. When you see 5 minus x and x minus 5, what should you think? Hey, those are almost the same except what? The subtracting order got flipped. That means one is just the negative of the other. Okay? Because look, if I factor out a negative, then I get negative 5 and positive x. So really, 5 minus x is the same thing as x minus 5 with a negative factored out. See that? So then if I cancel those, then I get negative 1. Does that make sense? Alright. Note that in all these cases, we assume that the denominator doesn't equal 0. Why do we assume that? Because you're not allowed to divide by 0. So for here, what do we know? That x cannot be what? 5. Because if x was 5, then this would be 5 minus 5, and then we get 0, and we can't have that. Okay? Does that make sense? You guys want to get a snack? Yeah, go get a... Yeah, no? Okay. Okay, we could keep going if you don't want a snack. Okay, well, be quick if you're going to get a snack, and we're... Let's go really fast. Just joining us, we read from this box on how to add rational expressions. Okay, and we talked about the box time method. When you're adding rational expressions, then I'll clip that part out. So basically what we talked about here was simplifying rational expressions. Simplifying rational expressions. Just reducing, canceling out common factors. Now we're moving on to adding rational expressions. And now we're doing these practice problems. Alright?
Cheeses are not popular today.
Oh, there's cheeses?
There's cheeses, miss?
I didn't know.
This can I turn my 2.3.5 today?
Wait, what period are you first?
Yeah.
I just need your help with something real quick. Or it's fine. You can.
Come on, do these problems, guys.
Everyone, Johnson.
Do you have any questions?
Good one, man. Thanks.
Are you guys doing okay? Oh, you did all three of them already? Yep.
Like, where does 2.3.5 start? Because this is 2.4, 2.3.4, and then
Okay.
so then 3 to 131. So just 4 questions.
Hola, señora! Exclamation point. Lindsay está conmigo en tutoring.
Miss Han, I have a question.
Oh, don't talk. No. How do you say exclamation point in Spanish? Punto exclamación? You know what? Hola, señora. Lindsay está conmigo en tutoring. No me entiende. Lindsay está conmigo en tutoría. They called you Versi. Yes, I'm eating. Alright guys, let me show you how to do it. There's A. Does anybody have a question on that? Okay, the next one. Oops. Okay.
Oh, you did it like, okay. I was like, what? That's already.
Oh my gosh. And I was like,
Yeah. What? No, I put in an announcement that you guys needed to turn it in. There was an announcement during the bathroom break. Yeah. Period 1 needs to turn it in.
No one from period 1 even turned it in.
No, they came. The people that heard the announcement came.
Where's your...
Yeah, right now. Okay, am I done?
We tried to miss, but.
Are you accusing me of poor planning?
Huh?
Are you accusing me of poor planning?
Well, yeah.
Well, you knew that it was due. You should have turned it in.
It's fine, you didn't ask for it.
But you knew it was due. You should have told me.
When
Okay.
teachers forget about collecting homework, they don't mind.
So bad ethics on your part does not mean that it's not due. Okay, can we factor the? Okay, wait, are we done? Why not? Why the X method? What does that mean? What's the X method for? Factoring the top, because what if we can factor something out that cancels on the bottom? Maybe. If not, then that's it. But okay, we could. Can it? Oh, okay. Let's make sure though. What two numbers multiply to negative 20 but add up to 2? Oh, your name wasn't on it. We didn't know whose it was. 4 and 5, 1, 2 and 10. That's it. 1 and 20. So none. Okay, so we can't factor it. We can leave it. If you want to factor the bottom, you may. But you don't need to. Oh, that's where I started off with. Ha! Yeah. Okay, any questions on that? Alright. Now what? 6 times x minus 2 minus 4 times x plus 2. Do you guys notice how I still keep my train tracks? Are you guys doing that? Oops. Okay, don't look at my answer until you've tried it for yourself, okay?
It's my writing. When senior hits hit too hard.
Anti-differentiation. Can you help me with that?
Yes. Whoa, 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 whoa. This is being recorded.
Oh my god. That's embarrassing.
Okay. This one?
No, not this one. We have to anti-differentiate that. So, okay, it got to the bottom.
Well, you know, you always struggle with these kind of fractions. Can you rewrite that?
Yeah, you can bring it to the top. Or you can bring it, or you can
You write that just as a product?
Oh, yeah.
Okay, did you guys get to this? Any questions on how I got there? Now, I might want to just factor it. I don't have to, but it's kind of nice. If I factor out, what can I factor out from the top? 2. Then you have x minus 10. Now, can that cancel out with anything on the bottom?
No.
No, but here's, everything's perfectly factored. 2 times that over that times that, and there's my answer. Okay? No. Okay?
Wait. You said bring it.
Yeah, but fine then. 4 also has to be negative 1. Because this is a denominator.
I thought only when you bring it to only the exponent turns negative.
I know, the exponent here is 1.
Oh, 4 is. Oh, it's a constant.
That's a 1/4, right? It's not a 4. 4 and 1/4 are very different.
Okay.
And so you have 1/4 x to the negative 1/4. I want you to think about what you do when you take an exponent. When you differentiate it, it becomes n times x to the n minus 1. So if you want to undifferentiate this, you have to
Bring it to the front.
add 1 and divide by that, right?
Add 1 and divide by it.
So if I already have this, to get here, I have to divide by n and add 1 to this, right? Try it with a few actual numbers. Oh, you guys, you wanted some harder ones? Sure, try these.
Which one, Miss? Is that like a whole problem or?
Oh, wait.
Where does it start? Where does it end?
Okay, guys. Yumi, are you here to socialize?
I'm not even talking.
No, that's not my question. Are you here to socialize?
No.
What are you here for?
Rational expression.
Oh, you are? Then you need to get a whiteboard and paper out and sit over here.
Oh, this calculus.
What are you guys here for?
I was working on calculus.
Okay. It doesn't take long to get ready to leave. How long does it take to get ready to leave? You can stay if you're gonna work, but if you're gonna just get ready to leave, you could get ready to leave outside. All right, you have 5 seconds. All right, okay, good. You guys, this one, you know what? Let's skip this one for now because this one is not quite as. This one.
C? Or which one? All of them?
Wait, what number is
All of
that?
them. This is 77.
This 77?
All of them?
Yeah.
Hey man, that's my charger.
Oh, that's easy.
You know that this is what the Algebra 2 class is doing this week? No. Just to remind you, you should learn this before.
Think fast.
So are you gonna have tutoring on Monday, man?
Am I going to have tutoring on Monday? Yes.
Are you gonna have it at lunch also?
Yes. Okay, hurry up, you guys. Focus.
Not that one, this on the third.
See, now you gotta move.
Wait, no, you don't get x. You're multiplying the negative. When you like that, it's 2x squared. Yeah.
Actually, can you borrow this? Yeah. First, make sure it works well.
Right, for the exponent,
No,
when you
Mr. Papa
multiply
just
them,
gave us
you add
this.
the
Okay, make sure it works. Make sure the batteries work.
It's 2x squared.
How do you check whether the battery's good? It doesn't say like the battery? Does it tell you how much battery? Do you have a calculator? Josh, you get minus x squared?
Minus 1x? Oh, plus 1x.
Oh, yeah, 45.
You do this. Plus 2x. Are you sure?
Oh yeah.
But why is it a sausage? I don't
The isosceles triangle is one that's the same size, right?
Isosceles triangle. That's 2x.
Okay, guys, let's talk about this. Are you guys ready to talk?
Yeah, first one, yeah.
Okay, let's do one at a time. For the first one, by the way, this was on your RMPs. Did you guys do this on the RMPA? Was it easy then? Okay, so we're gonna do this times this. So x. Shh, you guys. Wait, Jonathan, are you done with your test? Okay, this times this. Okay, well you only have 20 minutes, but you have another test to finish. So, can you sit somewhere like test-like? Times this, okay? All over this, right? Yeah? Okay. All right. Now what? What should you do next? Distribute. So we have x squared minus x plus x squared plus 2x plus, wait, x squared plus 2. X plus 2x, so it's 3x, right? Plus 2. Okay? Are you guys with me?
Yeah.
Now what? Start combining like terms. What's x squared plus x squared? 2x squared. What's negative x plus 3x? 2x. And then that is 2. Are we done? What should we do next? The bottom? What about the bottom? Multiply? No, Lourdes. What we're trying to do is factor everything, not multiply everything. We're going to do the reverse. We're going to factor everything, because if we factor everything, maybe we can start canceling stuff out. But you could only cancel stuff out once you have factored it, right? You guys, could I have started canceling this year? Woo! X minus 1, cancel. X minus, no, right? That's the couch block thing, right? And the red flag thing. We cannot do that. What can I factor from the top? There's a greatest common factor there. So x squared plus x plus 1.
And now do you do x method?
Yes, but remember, before you do any factoring, you have to always take out any common denominators. Daisy. Grab her. Okay, now I have a feeling that we're not going to be able to factor this, but let's just make sure. What two numbers multiply to 1 but add to 1? 1 plus 1 equals 2 though. So it's not possible. So that's my final answer. If there's any left. Tell your cousin that on the Thanksgiving packet. Can I have my wait, where did I leave my Thanksgiving packet? Did I leave it over there? Oh, over there. Jesse, can you pass me the packet behind you? Tell her that the 2 worksheets I gave you, plus on her Thanksgiving packet. Did I already tell you this?
On her Thanksgiving packet.
Oh, no, wait. Did I give you 3 sheets? Oh, never mind. You're good.
Okay.
Go ahead, Grace. Okay, do you guys feel good about this?
Yeah. You add CA was 2CA?
No. CA plus CA. What? Oh, that's a good question.
It's not 2CA, right?
2CA, yeah.
But then
It's something plus something equals 2 of the something, right?
Okay, so it's just 2CA, not 2CA squared?
2CA squared. 2CA squared means 2 times CA times CA. Are we multiplying these? No. Okay. So whenever you're not sure and you have an idea, try them out and see, and then write it out and see if it makes sense.
Okay.
That's how I do it. Okay, so let's do B and C.
CB minus CB.
No, come on now. I'll run 7. Gotta go to.
Don't tell me what I should
Okay, you guys, you know what? Because of time, I'm just gonna go through these with you, okay? You guys tell me what to do. Okay, what should I do first?
multiply the denominator.
Yeah, after the parentheses, of course. Okay, so C times A plus B. Oh, that's confusing because that looks like a C times A plus B plus C times A minus B. You mean equals. Okay, then I'm gonna do what? Distribute. So CA plus CB plus CA minus CB all over. You don't have to, because the goal is to factor. When you do working with rational expressions, remember, we want to factor everything. The goal is to factor everything so that we can cross stuff out. Remember the first page? Yeah. When things are fully factored, we can cancel them out. So that's what not like this, but like this. And so the only reason why we distribute this, though, is before we can factor everything, we have to simplify it. So we have to distribute so we can combine like terms, simplify it, and then factor it. So you like unwrap it so you can wrap it all again. Okay? Okay? So CB and minus CB, those cancel out.
Yeah.
What's CA plus CA?
2CA.
2CA over A minus B times A plus B. Okay? Does that make sense, guys?
Yes.
Okay, for the sake of time, I'm going fast. Okay, I'm gonna. Okay, good, Lou. Okay, so it's 6x squared times x plus 2 minus 3x times x plus 1 over. Oh, how do I multiply those? 18x cubed. You see that? 18x cubed. All right, now what? Distribute. Okay, so at 6 what? X cubed plus 12x squared minus 3x squared minus 3x all over 18x cubed. Woo! Then I'm going to do what? Combine like terms. Those are like terms. What's 12x squared minus 3x squared? 11. No, 9x squared minus 3x all over 18x cubed. Okay? Okay. So true or false? Since there's an x cube here and an x cube here, I could cross them out.
No.
Why not? You can only cross stuff out once everything has been factored. Only when you're multiplying and dividing stuff, not any adding. That's like the couch block thing, okay? So what should I do first? Am I done?
No.
Not simplify. What's the word, guys? We gotta factor the top. In order to factor, what do we need to do? Before you do any method, take out any greatest common factors, such as what? 3. What else? X. Good. If I take a 3x out of this term, I'm left with 2x squared. If I take a 3x out of here, I'm left with 3x and minus 1 over 18x cubed. You see how the RMPs, each problem gets harder and harder? If you give up after doing the first problem, that's when you end up failing the test. You gotta go all the way.
I only do the first 5 and
The RMP?
See, that's the problem. Yeah.
No, it's not.
No, what I mean is within a problem like A, B, and C, you know?
Yeah, because there's like A, B, and C, and it's like pretty different.
Anyway, okay, so, alright, am I done?
No.
Why not?
Because you can factor more. Yeah.
Can I factor this anymore? Do I have any greatest common factors? No, so what do I do now?
The factoring of x.
The factoring x method, right? So 2 times negative 1 is negative 2, and then 3 is there. So what two numbers multiply to negative 2 but add up to 3? Nothing? Man, I was hoping. Well, the only factors of negative 2 are 2 and 1.
But then if you add them, it's like.
But then negative 2 and negative. Oh, you guys are so smart. And so that we're done. Oh, wait, are we done? Can we cancel it? So basically, we have everything factored, fully factored. But can I simplify these? Can I? Okay, 3 over 18 is what? I could factor out a 3 out of here, and I get 6. And I could take out this x and take out one of these x's, so I'm going to be left with squared. Okay? Neko senso? Okay. If you want more practice, like the more difficult ones that you'll see on your test, go back to this packet, okay? In your Thanksgiving packet, and try again as if for the first time. You know how you're like, can you give us more worksheets? I give you so many worksheets, just do them again. You know you don't remember the answers. So try these, okay? These aren't adding, but once you've already added, what do you have to do to see if you can simplify? You have to what? Factor. See if you can factor and cancel stuff, okay? But we haven't talked about this yet. So we do need these last 10 minutes to talk about this. I even started on the packet. Yes?
Well, I finished everything, just I don't get A, B, and C. Well, I get some of A. A's easy, but B, I don't know.
Okay. You looked at the hints?
Well, no.
10? Come on. Alright, guys. So, oh, my nails are breaking. Okay.
Can I do this at home?
No, it's due today. Don't be lazy.
Why is it due today?
Because it was due like a month ago.
But you... God.
Alright, you guys. Okay, shh. We only have 10 minutes. Okay, so what about when you're multiplying rational exponents? Okay, that's totally different from adding them. You don't use the bow tie method anymore. Okay, Anthony? It's a different method. Okay? When we were adding rational expressions, we use this bow tie method. Where'd it go? We use this, right? And remember, we did that because we tried to get the common denominator. But when I'm multiplying, I don't even need a common denominator. Multiply across on the numerator and multiply across on the denominator. Okay, right, Yumi? Okay, when multiplying and simplifying rational expressions, it's necessary to first factor both the numerator and denominator before canceling. Remember, before we cancel, what do we always have to do? First factor, then cancel. Okay? For example, if I factor x squared minus 4, it's x minus 2x plus 2. If I factor this guy, it's x minus plus 2, x minus 3. And I factor that, then I could cancel out anything that's the same. Okay? What about if I'm dividing rational expressions though? We didn't do that very much, but is that not on here yet? I guess it's going to come out a little later. Do you guys know how to divide rational expressions? What if this was a division symbol instead of a multiplication symbol? Copy, change, flip. That's right. Okay? But let's focus on the multiplying for now. Okay? Can you guys do number 114? Well, you know what? We got to go soon, so I'll do it with you. Okay? Ooh, let's do the hardest one. Okay. How can I... Oh, whoa. This is not even two fractions. It's one fraction and one expression. What do I do? Do I have to start... Yes, thank you, Nichelle. Don't start screaming. It's actually still a multiplication of two fractions. Just put it over one. Okay? Now, so it's this times this over that times that. But the thing is, can I factor this x squared minus y squared? What is that called? What do you... Difference of squares. What's x squared minus y squared?
What's the question?
How do I factor this guy? Oh, hold it, Kevin. Hold it. I know you know it. What?
Oh, never mind. I thought you took it an X and Y. Isn't it X plus Y and then do it again?
X plus y and do it again. X plus y again? No. Yes. X plus y times x minus y. You guys agree?
Yeah.
Okay, now let's factor this guy. What can we take out of that guy?
4.
Why are you talking, guys? 4x. Thank you. If I take out a 4x from here, what's left? X. And what's left here?
Y.
Oh, plus y, excuse me. Okay? You cool with that?
Yeah.
All over, what's this?
Oh, it's so. Same side.
Okay.
That's actually x plus y plus.
I was just kidding. I don't know what I'm
Okay, you guys, you need to recognize this as being the square of sum. Okay? Okay. No. The square of sums. Okay, now. Okay. Let's do the... I know you guys do like the box method and stuff. I do by grouping as well, because when you see this 2xy is really xy plus xy, right? So let's do that. I'm just going to take this whole thing and I'm just going to bring it over here, okay? Just to learn how to factor it over here. X squared plus 2xy plus y squared. Can I split this up into xy plus xy?
Yes.
You guys agree with that? And so I have x squared plus xy plus xy plus y squared. Do you guys agree with that? Okay. Can I group this and group that? Is that okay? What can I factor out of here? An x. So I'll be left with x plus y inside, right? Yeah? What can I factor out of here? I'll be left with x plus y here. So, do you guys see how there's an x plus y in both of these?
Yeah.
Can I factor that out?
Yeah, and then it would be X plus Y.
And then what's left?
So it could just be squared.
So that's just x plus y squared.
That's unnecessary. Why can't they just write across and
So, if I have x plus y, that's the square of a sum, right? But you guys need to memorize this. This is one thing, I know I don't normally like to have you guys memorize stuff, but whenever you see x plus y, that quantity squared, you should know that is the same thing as x squared plus y squared plus 2xy. You guys don't remember that?
Yeah.
For example, if I had asked you to do x plus 3 squared, wouldn't you know right away that that's x squared plus 6x plus 9? Would you know that?
I would do that.
You would do the whole thing?
Yeah.
Well, once you do the whole thing, you would soon figure out the pattern. It's x squared plus 3x, but this is the same, 3x and then 9. Okay? And do you see how that ends up being just 3 squared and x squared and then 3x doubled? You see the pattern? So when you see this, they're expecting you by now to recognize that that is that. Now, if you paid attention to the Thanksgiving packet, which I was hoping that you all would, because I told you it was so important, then you would have gotten that. From where? Where is it? I know it's here. I saw it the other day. I'm not making this up, but I can't find it. Okay. Anyhow, that was in something somewhere. Right here, right here, right here. Okay. You know what? This was not in the packet. I was lying. Just kidding. But this was in. I did send it to you guys on Schoology. Yes, it's working. Okay. So you guys need to have these memorized, the special products. When you see a plus b squared, you should know that's a squared plus 2ab plus b squared. Okay? When you see a minus b squared, you should know that's a squared minus 2ab plus b squared. And then you guys learn the rule for cubes. Is that the soaps thing you're talking about? Okay. And then difference, okay, I'm not even expecting you to know the cubes yet, okay, even though you learned it in Algebra 2. But can you please at least know the ones that are from Algebra 1, please? Okay? Difference of two squares, a squared minus b squared is a plus b times a minus b, yes?
Yes. So wait, so how do you remember it? Like, you'll know that the x is squared, and then it's plus, like, the number times 2,
The two numbers multiplied times 2, and then the last one squared. Okay? So let's go back to the problem at hand. If you see this on the bottom, what are we going to recognize that as now?
x plus y squared.
Yes.
And don't forget it.
Which is really x plus y times x plus y, right? Now that everything is what? I can do what? Now that everything is factored, I'm allowed to cancel out. What can I cancel out? There's x plus y times x plus y here. But look, I have 2x plus y's. So I could just cancel those. I'll take your 2 for my 2. Yeah? Even? Deal?
Yes.
So what's left?
X minus y, 4x.
There you are. Okay? So if you want to know how to do the... Okay. So use your Thanksgiving packet, guys. Is your name on it?
Right here, and the first 2
Where?
Oh, well, the first 2 pages.
Okay. Put it over on my desk.
I still don't get the hint.
Miss Hannah, I corrected this one.
Okay.